Welcome back to the Super Data Science Podcast, everybody. Super excited to have you back here on the show. And today we've got a special guest calling in from New York, Asieh Ahani. I hope I pronounced your name correctly. Welcome to the show, Asieh.
Thank you very much. Yes, it was correct.
Awesome, fantastic. Well, excited to have you on the show. How's New York these days? Is it like we already talked a bit about coronavirus? Is it cold? Is it warm? Is it like how's the weather? How's the winter going?
Yes, it is getting cold, which is sad because the city was on lockdown in the summer, so we couldn't really enjoy the warm weather.
Mm, mm,
So it's sad that it's getting cold, but I like fall. So
mm. I see you've got a lot of plants in your house. You like to have a lot of nature inside.
yes, there's not much nature outside, so you have to compensate for that.
Yeah, yeah, okay. And are you far away from Central Park?
I am. I live in financial district, so
Uh-huh.
it's at like the edge of the island, and
Uh-huh.
Central Park is in the middle. So I'm not
Uh-huh.
very close to that.
Yeah, yeah. New York is huge. It takes a long time to walk that distance. So you're near Manhattan, is that right?
Yeah, I am in Manhattan,
In
but I'm
Manhattan.
at the edge of the island in financial district where the World Trade Center and 9/11
Ah,
memorials are.
okay, okay, gotcha. And you have a very interesting story. So, before New York, you were in Boston, and before that, you originally are from Iran, if I'm understanding this correctly. Walk us through this. Like you've studied at several different universities, you've traveled the world. Would love to hear how it all started.
Yeah, I mean, it all started in high school. I always loved math, so I was very much involved in a lot of like different extracurriculum courses around mathematics and statistics. And that's why I chose electrical engineering communication for the college degree. I got my Bachelor of Science in Ferdowsi University of Mashhad in Iran. That's the city that I'm from. It's in the eastern part of Iran. Um, and I studied in electrical engineering because to me that was the field within engineering that was mainly using mathematics and statistics compared to physics or the
Mm-hmm,
more applied
mm-hmm,
sciences.
mm-hmm,
In retrospect, I should have gone to theoretical math instead of engineering, but at least I think I found my way along the way. And then I moved to Boston I moved to Tehran, which is the capital of Iran,
mm-hmm.
for my master's degree in bioengineering because I was very interested at the time in neuroscience.
That's a big shift from electrical engineering to bioengineering. What made you make that change?
Well, neuroscience is very much, so again, bioengineering have different fields. There are different fields within bioengineering. There's biomechanics, bioelectrics, and biochemistry. I chose bioelectrics, so it was
Mm,
very similar to electrical engineering. The only difference was that the application was in biomedical fields at that
mm,
time, the neural signals. So you're basically using the same statistical methods like signal processing or machine learning or probability theory, but to analyze brain signals,
mm,
not to analyze like electrical data.
mm-hmm, mm-hmm. Gotcha. So, you made the shift, and was it a good move? How did you feel?
It was, I think, because the application, again, the biomedical applications are really challenging, which makes it very interesting. I really love that shift. And
Hmm.
I think I learned that you don't have to be afraid of just changing course
Hmm.
because you might find something that is more interesting.
Okay. Okay. Awesome. And so you completed your master's in Tehran, and what happened after that?
I think at that time I was just trying to decide whether I want to pursue a PhD degree or not. And I applied for a couple of universities. I got an admission from Northeastern University from Boston.
Hmm.
And I realized, okay, that's a good challenge.
Hmm.
Not only I have to change my country of residency, also I can pursue a higher degree. So I moved to United States.
Okay. And what was the PhD in?
My PhD was also in bioengineering. My advisor was in electrical engineering department, but most of his projects and funding were in
Mhm.
bio fields, specifically neuroscience and brain-computer
Mhm.
interface. That's why, although I was in the bioengineering department, I was working with an advisor who was in electrical engineering department.
Okay, so your past continues, right? Your bachelor degree. All right, so bioengineering, neural science, um, and if you were to describe bioengineering, especially the electrical part, to somebody, what is it all about?
Um, it's about signal processing and
Mm.
machine learning, I think. I mean,
Mhm.
at least the area that I was involved with. Uh, our brain, even our body, the muscular, our muscles, there are so many data that you can collect from a human body,
Mhm.
specifically brain, but not excluding the brain. And there's a lot that you can do on that data, not only to
Mhm.
understand the biology, but also to use that data in order to help people that uh, have any sort of disability, whether it's um, visual disability, brain disability, or physical disability. And that's basically everything is based on signal processing that data, and then machine learning, which means coming up with prescriptive
Mhm.
analysis based on that signal processing portion.
Awesome. This episode is brought to you by Super Data Science, our online membership platform for learning data science at any level. We've got over 2,500 video tutorials, over 200 hours of content, and 30 plus courses, with new courses being added on average once per month. So all of that and more you get as part of your membership at Super Data Science. So don't hold off. Sign up today at www.superdatascience.com. Secure your membership and take your data science skills to the next level. And can you share with us what was the main topic of your research for your PhD?
Yeah, I was doing both signal processing and machine learning. I did analyze a lot of EEG data to understand the changes in brain signal when somebody is meditating, and what is the changes in EEG. And also, I used machine learning to develop brain-computer interfaces. Brain-computer interfaces are basically tools that you train to collect the data from humans' brain and then translate that into a robot to perform the action that the human wants. For example, you want to move your arm, there is a signal going on into your motor cortex, and a brain computer interface device can detect that and moves a robot arm. So you're basically moving that arm using your brain without even moving your arm.
Wow.
My project was detecting attention signal just to help people with disabilities who cannot move their hands to build a brain computer interface keyboard. So let's say, for example, I can show you A, B, C, D, E, F, and you are actually looking for the letter E. When you see E, there is an attention signal in your brain. This is what I'm looking for.
Oh.
Our device could capture that attention signal and type E for you. Basically,
So you're not even doing anything. You just see the right one. You don't even have to point with your eyes or anything like that. You just see the right one, and because you have the letter in your head already, something different happens when it. Wow.
Yep.
That's so cool. Wow. So and you and I'm guessing because we technologically we're still not there. You were doing non-invasive, like signal reading. Like it was with like is that called the EEG device when you have like this all these sensors on your head, but there's no surgery. There's no like invasive connection with your brain. Is that correct?
That is correct. Yes, it
Okay.
was mainly non-invasive. In my master's, I was working on some MEMS technology to build biosensors that you can actually implant in someone's brain. But I changed my course. Instead of going to that like MEMS field, I moved to more machine learning and signal processing field.
Okay. How accurate are these EEG devices?
I mean, depends on what type of signal you're trying to collect. So the signals such as attention and visual or motor cortex are pretty strong. You should be able to actually collect them with a high level of accuracy using EEG. But then you go into cognition. How can I understand someone's behavior or emotion using their brain signal? I don't think EEG can help you that much.
Okay, gotcha. And very interesting field. Very interesting. So, what kind of machine learning techniques did you use for processing those signals?
Yeah, we use a lot of, first of all, I think the biggest challenge is curse of dimensionality. So when you want to train a classifier, you have a limited amount of time to train a classifier. It means that you have a low number of observations, and the dimension of the data is real high. So using different algorithms to reduce the dimensionality is key. So we used a lot of that. And then after that, we did kernel analysis and classification theory to classify the brain signal. For example, in this example of brain-computer interface keyboard, when you see A, B, C, those are the data points that is not your desired data points. So in the target class is 0 for them. But when you see D, which is the letter you're looking for, it should be target class 1. So first separating that data and building a classifier to train on these like training data set, so that next time that you're looking for the data that is your desired letter, the classifier can actually detect that and classify that accurately. So a lot of classification, regression analysis, and also basic signal processing work to remove noise, clean the data, and again, reduce the dimension of the data.
Okay, wow, there's a lot there. Let's go through those step by step. So, curse of dimensionality. Can you please refresh my memory on what is the curse of dimensionality?
Yeah, it's generally when your dimensions are more than your observations. That means the covariance matrix, you cannot calculate the inverse of the covariance matrix, obviously. So what you want to do is to reduce the dimension of the data. So there are many transformations that you can do on your covariance matrix. You can do regularization. You can do shrinkage, which means that you shrink your covariance matrix values toward the pooled-in average. So your eigenvalues are actually like not all 0. So you can actually calculate the inverse of the covariance matrix. And regularization as well, you want to shift the values of your covariance matrix against toward the pooled-in average. With that,
this is also easy to use. Sorry to interrupt. It's gonna sound funny. Can you refresh my memory, please, on what is a covariance matrix? I know it might sound really obvious to you, but I need a refresher.
Sure. I mean, EEG data is, you have a Gaussian assumption on an EEG data. We assume that EEG is Gaussian. It might not be, but that's the basic of machine learning, right? You have to assume that my data has this a specific form, so I can use this model to solve it. And for EEG data, oftentimes you have that Gaussian assumption. So
normally distributed data.
Exactly. It has a normal distribution, but it's multivariate, right? So when you try to solve a multivariant Gaussian model, you have to solve it using least square method, which is which is basically it's not a linear. You cannot solve it in a linear form. That's why when you actually want to solve a Gaussian model using least square method, you need to calculate the inverse of the covariance matrix. And when your dimensions are higher than your observations, means that the eigenvalues in your covariance matrix are mostly zero. And it means
Mm-hmm.
that the covariance is not inversible.
Mm-hmm.
And that's when you have to reduce the dimension of the data to make sure that you can calculate the inverse of the covariance.
Okay. And so you could use something like principal component analysis to reduce your dimensionality.
You can do that. We did, again, there are multiple ways that I can do it. We did regularization and shrinkage in this specific project. It's all about which methodology gives you the best accuracy. For us, this methodology, regularization and shrinkage, provided the best accuracy.
Mm-hmm. How can you describe regularization?
Yeah. So regularization means that you're looking at your covariance matrix. This is just an example. It can be any analysis, right? You have a matrix and you want to regularize matrix. It means that you want to shift the value within that matrix toward the pooled in average so that your eigenvalues are not mainly zero or most of them are zeros. That's regularization.
Okay, gotcha. Understand. Okay, and then you also mentioned you would build a classifier. What kind of classifiers did you build in this project?
I have to remember. I think we did kernel density estimation, which means that you're basically, what is a kernel, right? It's just if you plot all your data points in the two vector plot, you can actually draw a circle around your different classes, and that's what's called kernel radius kernel analysis, which means that I'm going to design kernels and the shape of the kernel is a circle. There are different ways that you can build kernels. It can be a stochastic or it cannot be non-circular. We use circular kernel analysis, and based on that, basically found the center of the kernel and the radius of the kernel. And then we trained our data based on that kernel density estimation. And then when you have a new data point, we just see where that data point resides, whether it's kernel 1 or kernel 2. And based on that, we did the class.
Okay, so you would use something like a radial basis function.
Exactly.
Okay, gotcha. It's interesting. A lot of this is coming back to it because we teach this in our machine learning course, and we did kernel SVMs, for example. The RBFs was there.
Yep.
Yeah. Okay, cool. Thank you very much. That was a nice dive into the technical details, and it's interesting to hear that a lot of these machine learning concepts that you could be using like for marketing or for business or for, I don't know, some other applications, predictive model maintenance and things like that, can actually be used to understand better what is going on in the human brain, and that's very, very interesting. One that we don't normally encounter in like, for example, business or in other industry applications is signal processing. That's something that you did use quite a lot. And that probably comes from your electrical engineering background more than from machine learning. Is that right?
Yeah, I mean, I wouldn't say all industries. I feel like probably finance uses a lot of signal processing, maybe a stochastic signal processing, not like linear or autoregressive. But not in marketing, which is my field.
Yeah. Well, if you could give us just like a few words on signal processing, like what is the essence and what is maybe some of the basic types of signal processing? Like I know, for example, moving average is a type of signal processing, but that's really basic, right? So what are your comments on that? So for people who haven't encountered signal processing in their careers.
So my experience have been mainly on like deterministic and non-deterministic signal processing. I think that's the highest level of classification, right? Because if it's deterministic, then you can, moving average is one way of modeling that signal. Autoregressive models are one way of modeling that. Kalman filtering is another way that you can actually model a deterministic signal. And then when it's undeterministic or stochastic, then you go into, again, you can use autoregressive, but it's a stochastic autoregressive analysis, which has a stochastic component to it. Those are the type of signal processing that I'm familiar with, but mainly on the deterministic data and non-stochastic ones.
Okay. What's the difference between deterministic and stochastic signals?
Yeah, so in the deterministic one, you assume that the pattern in your signal doesn't change in time, so you're repeating the same pattern.
Uh-huh.
In stochastic, you have that stochastic assumption that your data is not deterministic with time and is changing. Examples of that is weather, stock market,
okay.
gas or oil prices.
Like a heartbeat would be deterministic. It repeats.
Yeah. Or EEG.
EEG also deterministic, right? There's a lot of variety in it, but it's if you were able to classify all the variety, it would be deterministic.
Yep.
A Brownian motion would be stochastic, right? Because you don't know where it will go. You can't predict where it's going to go.
Yeah,
that's my guess. I'm not sure about that, but basically, I get your point. So stock market would be stochastic. Thank you. Very, very insightful.
History will be a stochastic.
History, well, some people say history repeats itself. So
I know that's not accurate. I think that's a problem, right? We try to oversimplify very complicated concepts. So history is one. Actually, history is the most stochastic signal I can imagine because it's a combination of stochastic human data. I am a stochastic, you are a stochastic, and our collective behavior defines history. So it's really the most stochastic data you can ever imagine. Because then the only reason that I can make it deterministic is I can predict every individual human's behavior, which you can't.
But what do you say when some psychologists say, for example, that, or economists say that it's really hard to predict the behavioral patterns of one individual human, but it's much easier to predict the patterns of like a group of humans, or the bigger the group, the easier it is to predict like the group mind and how people are going to behave and think. So don't you think that maybe if you put a lot of stochastic individuals together, in total, it might the combined system might actually be less stochastic than the individuals themselves?
Yeah, I definitely agree. So again, I agree for building analytics on human behavior and find a group mentality of a group, or as a society, where are we going and how different groups are interacting with each other. It's very difficult to come up with prescriptive analysis. So I'll give you a very simple example why a stock market is stochastic. So if I can build a very good model that will give you the price of Apple stock tomorrow, you're going to buy and sell based on that assumption. So your buying and selling that stock will change that prediction. So it's by nature stochastic. Even if you can predict it, the action you make based on that prediction will change that prediction.
So it's like a paradox.
Exactly. It's the same thing goes with history. Even if we can cluster and then try to do something, people will then behave and react based on that. And then again, it becomes unpredictable.
Oh, okay, gotcha. That's a very simple proof, right? Like of the theorem. Very cool. Thank you very much. Well, that was a very interesting dive into your research and your academic background. Let's talk about your career. So, at which point did you decide to pursue a career following your PhD in this space? Why didn't you stay in academia? Why did you decide to move into the industry?
Yeah, I can say it was a combination of chance and confusion. And I think that's something that most PhD students deal with at the end of their PhD. They have this question whether I want to stay in academia or want to go to industry. I had the same dilemma as well. And actually at that time I was looking for postdoc positions because I wanted to stay in academia, specifically in Europe. I went to leave US at that time. And then I thought I can't leave without having some experience in industry. And I found an internship in Visual IQ, which was the company that I used to work before moving to MassMutual in Needham, Massachusetts. And that internship experience was very good. because I think I was leading one of the most important projects they had at the time, not only to automate that, but also to building algorithms. And I found that data science has a good combination of everything I'm interested in: problem solving, programming, and also not putting yourself in a specific academic box. You can actually have a client facing position, you can talk to clients, you should understand the business. So there's a lot of non-technical skills that I can learn if I work in data science versus if I stay in academia. And that's when I decided to move to industry.
Awesome. What were you doing at Visual IQ? Are you able to share this project that you said was one of the important projects that you were leading there?
Sure. I was working on marketing attribution projects. So basically, when um, every company uses different channels to market. So you can use TV and radio, you can use paid search or paid social or organic social to advertise for your company. So mixed media marketing and marketing attributions are about attributing your conversions and sales to different marketing channels. And how to attribute that is very challenging because, for example, if you see a TV ad and you go and buy a policy, there's no way that you can link that together, right? So what are the modeling and methodologies that I can pick to attribute your sale to different marketing channels, offline and online? Was a very interesting theoretical problem.
Yeah, that's very interesting. How did it feel moving from working on brain-computer interface and meditation and like signal processing to marketing, which is like completely two different worlds, even though some of the perhaps like a lot of the skills are transferable in data science, but the underlying essence is different. Did you feel like how did you feel? I'm just curious.
It was definitely a change. In academia, a lot of concepts are very abstract. It's not practical. So again, brain-computer interface is different. It's very different. You know what you're trying to do. You want to move a robot arm, but most academic concepts are very abstract. But in industry and in marketing, things are actually pretty pragmatic. I want to increase my number of customers by 10%. I want to reduce costs in this part of operation. I want to retain my customers. How can I find customers that are most likely to lapse? And I reach out to them. So very pragmatic use cases. And then oftentimes there's no solution. Somebody tells you, this is my business problem. Go figure out how you want to solve it. And that's where the interesting part comes in, that you have to just come up with a hypothesis. You have to test that hypothesis. And then the last and most important part is to really understand how does this hypothesis will work out when you actually implement it in the business. So it's very different, as it's not only technical. There's so many different factors in it that just makes it way more challenging, at least for me.
Okay, understood. All right. So, and after Visual IQ, where you did the internship, and then you were quite quickly went from intern to data scientist to senior data scientist in a matter of 9 months and then 5 months. Then you moved to MassMutual, where you are the head of data science in the customer journey division. Tell us a bit about that. Maybe let's start by tell us about MassMutual. What is this? What is the mission of this company?
MassMutual is Massachusetts Mutual Financial Corporation. So MassMutual provides a variety of financial products. Most people know MassMutual because of the life insurance product, which is one of the biggest bucket of business for MassMutual. But MassMutual provides a variety of financial products such as disability insurance, annuity, different financial products, and also retirement services. I think MassMutual as a whole is, first of all, it's a mutual company. So all policyholders have a share in the company. And that was one of the reasons that I accepted the offer. To me, not having a private owner or even working in a public company is actually very interesting that you actually work
more fulfilling.
Yeah, you're working for your policyholders.
Mhm.
And I think the mission of the company is really great because these financial products help people to protect the ones they love. College can be afforded, retirements can be planned, and you can plan for the worst case scenario, which is disability or death. And to me, that's just that provides a service to the society that is actually much needed. And I really like the work that MassMutual is doing for the society.
Yeah, and it's a very big company. I'm just looking up the total of 7,000 employees in US, a total of internationally 10,600 employees, was founded over about 170 years ago, and the revenue in 2016, according to Wikipedia, according to the MassMutual website, was 29.6 billion. So it's a huge company, and it would be a very responsible role to be the head data scientist in one of the divisions at the company. Tell us about like your um, role. Like what is maybe how it's structured. So we were talking about the podcast at the start. You have data science and data analytics, and then in data science you have three domains. Can you paint this picture for us, please, so we know exactly or roughly how it all works?
Sure. We are a part of the DSA department, which is data science and analytics. And it includes data governance, data enterprise architecture, data science, and data analytics. My department, which is data science and data analytics, include both analytical teams and data science teams. And data science itself is divided into different domains, depending on what type of projects we accept and who we work with within the company. We have cybersecurity, the folks that are generally working in security and security domain. We have investment and finance, data science domain, and those folks may mainly work with investment management team and the finance department. We have risk and product domain, and they usually work on mortality models, pricing, actuarial, and all the different like underwriting processes, which is a big part of MassMutual business. And my domain is customer journey. So we are involved in every level of customer journey, from awareness, consideration, purchase. After we have a customer, there's all these post-issue operations, retention, loyalty, and making sure that contentment is high, and also cross-sell opportunities for our existing customers. And finally, claim, which is basically that post-issue operations efficiency, and also marketing and sales before we want to attract the customer.
Wow, that's a huge area of responsibility. So you would work quite closely with the marketing team, the support team, basically the marketing team and the support team, right?
Yes, we almost work with every part of the organization. I mean, it's great, but it's also the challenge because we're stretched because we have to work with everyone. So we had the prioritization and making sure that we focus on the most important business problems is really key. Otherwise, we will be buried under a lot of projects.
Gotcha. How many people do you have on your team?
Yeah, I didn't move to MassMutual as the head of data science. I was a lead data scientist and individual contributor for 2 years before I moved to my current position as the head of data science customer journey. I started with a team of, at that time, I think 6. Now we're 13 within a year.
Okay, wow.
So
That's impressive growth. And it's also impressive that with just 13 people, you can support an organization that employs 10,000 people. You must be so busy.
We are very busy.
Okay, gotcha. So I have quite a few questions here. The first one would be on your progression. So it's impressive to see how even starting from Visual IQ, it took you 7 months as an intern, 9 months as a data scientist, 5 months as a senior data scientist, then MassMutual 2 years, 3 months as a lead data scientist, and then head of data science customer journey, and where you've been for like just over 1 year. So very rapid progression through your career, right? From an intern to individual contributor to senior to a new company to head of a whole division for a giant organization. Can you tell us like how did that feel? Sometimes people stay in the same role for a decade or maybe 5 years, but you were constantly going up and up and up. Like, what was driving you, and what are like maybe the positives and the negative, the pros and the cons of such rapid career growth as a data scientist?
That's an interesting question. Actually, those are the things that I think about constantly myself, especially when you move from a technical role to a management role. That's the big change. And that means that you have to say goodbye to some of your technical skills. It's like inevitable, right? And we are in a very highly technical field. I think like 88% of people in data science have a postgraduate degree or some sort of master's or PhD. So it's a very highly educated and highly technical field. It's very important to have your technical skills. And when you move to a management role, you know that it's inevitable that you might lose some of those. So I would say that is something, I don't think that's definitely a concern or a bad thing, but it's a reality that you have to accept and you have to be prepared for. But there are much more to learn. Gaining all the soft skills, understanding how to delegate effectively, how to lead effectively. Those are really things that you won't learn until you become a technical lead or a people manager. Communication, learning how to listen, being more nurturing. I think a lot of like skills that I can actually use in your regular life. So those are the good things in moving up into your career because you're learning that. But I think that you also have to be aware of as your responsibilities change, you cannot like gain a lot of expertise in a specific area, which can actually be you can use that to your advantage in your career.
Okay, interesting. Do you ever regret the move into management, and do you miss the ability to just poke around in an algorithm and spend 3 days building a regression or something like that?
I don't regret, but I miss the different answer to the different adjective, I think.
Yeah.
Again, I don't regret it because I'm learning and growing, definitely, but I do miss technical work a lot.
Yeah.
I mean, I'm coming from years of technical work, and just moving to a management position has been challenging.
If somebody is in a similar dilemma as you were, is there anything that can be done for a manager to still maintain this technical expertise and not give it up completely?
Yeah, I do. So for example, every day after work, I solve a algorithm problem. I use different softwares. I don't know, for example, LeetCode or HackerRank, different sites that you can actually go and solve an algorithm problem.
Yeah.
To me, it's a good exercise because first I use Python, so I practice my programming.
Yeah.
And also it makes you engaged in actually solving an algorithm problem. I'm thinking about maybe also including building a model or solving a modeling problem as well. I know LeetCode and HackerRank don't provide that opportunities, but there are other websites that can actually go and solve a simple data science problem using Python or R. So that's something that I personally do after my work. Through work, I think there are managers who do both technical and management work. I think given the size of my team, I haven't had that option yet, but maybe in the future I can manage the team in a way that I can also do I can take some of the technical responsibilities.
Okay, amazing. Speaking of managing teams, Can you share some things that you've learned managing a data science team of 6 and then 13 people? Like, what are some of the main challenges, and what are some of the tips you can share with people who are considering becoming managers or who have recently become managers?
Yeah, I think the I think the most important thing is really first as a manager, increasing your business acumen and understanding the business as best as you can. And then the second layer is to develop your team to also understand the business. Uh, and I think that has been a challenge, especially when you have a company that is huge. Like you have 7,000 different people working in the company, different types of business, different financial products. Really understanding the business is really key, because you can actually frame the work of your team to be aligned with the strategical goal of the company.
Mm-hmm.
And then the second layer is to make sure that your team also understand the business and have that vision and direction to, I don't want to work on 100 different things. Let's understand what are the big business questions. Is it a strategic question for the company? And let's focus our attention on that. That to me has been the biggest challenge. And I'm learning even now on that. I'm trying to develop my team and push them toward that direction as well.
Okay. And
But
tips?
Tips are generally, I think, build on that business acumen side, building relationship and communication is key, and also building your influence, right?
Mm-hmm.
So basically building relationship with the right people and asking the right questions and coming up with effective solution is key. But also when you talk about people management, I think communication is really important, but also being empathetic to people's need, especially this year. It has been very challenging to be motivated and keep people motivated. That's what you have to as a manager. Not only you have to work on yourself, but you have to make sure your team is motivated. And it's difficult when you have a team in New York. They're all stuck in one-bedroom apartments trying to work from home.
Yeah.
Knowing how to listen and how to relate to people's problem has been key. I think that's very important to manage people. And also at the same time, making sure that you push people to be the best version of they want and keep them motivated and motivate them to do and work on important projects.
Mm-hmm. Would you say that management is in data sciences for everyone, or some people should really consider it and decide if that's what they want?
It's tough for me to tell. Honestly, I think humans are capable of learning anything. So it's difficult for me to say that it's not for everyone. I think if you are interested, you can learn the skills to be an effective manager. It all goes to whether you're interested or not. If you're interested, then you can learn, and you should just be motivated to learn.
Awesome. Gotcha. Thank you. And you also mentioned before the podcast that, well, we've got an exciting surprise for our listeners. You're hiring at MassMutual, specifically into your team. Tell us a bit about the roles and the candidates that you're looking for. So if someone listening to this podcast is interested, would be able to go out and apply.
Yeah, thank you so much. This is actually a lead data scientist position. So we're looking for somebody with experience. I think the job requirement is 7 years of experience, but we include some of the graduate degree as a part of the work experience. So I definitely want to have a diverse set of candidates coming in, and I want to make sure that I want to emphasize on people who are familiar with the industry, but also I don't want to exclude anyone who is not familiar, because I think people can learn the industry very well if they are really technically strong. So this position, this position is basically lead, which means that the candidate have to lead multiple projects at the same time. So it's very important to be agile and also be accountable. And also there's an opportunity to lead junior data scientists, because as the portfolio of lead data scientists grow and I have the multiple projects and competing priorities, it's very important to assign junior data scientists to those projects. So there's an opportunity to also develop the leading, learning how to lead people. So it's an exciting opportunity, and I would appreciate if people can apply, and please reach out to me on LinkedIn if you're interested.
Okay, so that's the best place to reach out to you directly on LinkedIn.
Yes, I don't have any other social media.
Yeah. No, that's okay. So I guess people should just put a note that they heard about this on the podcast, so you know where they heard it from. And does the person have to be in New York?
Not really. I think New England is preferred generally within a state of Massachusetts or New York, just because most of the team are either in Boston, Springfield, or New York. But given the current climate, I don't want to exclude anyone.
Awesome. And speaking of the current situation, how have you found? Before we continue, so anybody listening, if you're interested, make sure to find Asieh on LinkedIn and apply directly with her. So I was asking, speaking of the current situation, how have you found how have you found it leading a data science team, specifically a data science team? I know a lot of managers are learning a lot of new things in this coronavirus time, leading remote teams. But what are like some of the specifics around leading a data science team remotely?
Oh, it is challenging, especially when you brainstorm and you want to actually like formulate or write an equation. It has been pretty challenging. Fortunately, there are tools that you can use. For example, we use these tools that you can actually write on a notebook, and then you can share that notebook. So it's like it looks like a regular notebook, but you can connect that to the computer, and it's like you're writing on the screen. So that's good for brainstorming. But again, I think the biggest challenge is that communication and keeping people motivated. It's very difficult to do that when you're not sitting in the same office, or you cannot have lunch with your team or go for a coffee after work to make sure that you have that relationship. And I had to onboard 2 people. We hired 2 people in the middle of pandemic, so I've never seen them.
Oh,
2
wow.
people in my team, they were onboarded digitally. So it's for them, I feel like they often might feel isolated, right? Because they never saw me or anybody else on the team versus somebody who used to work before the pandemic. So those are like challenges that we face every day. It's just we just have to adapt.
And when you like work on when your data science team works on a model, how do they kind of like work on? Do two of the same people ever work on the same code? How do they share that, especially in a remote environment?
Yeah, so we do use GitHub, so it's easier to actually work on the same code when you're using like things like GitHub or different platforms that can share codes. I think the challenge is mainly when you're actually brainstorming, you're trying to ideate. So you think, oh, how about this? And you want to like easily walk to the board and start writing that down. And that's not an option when you're working remotely.
Gotcha. All right. You're quite, I can imagine you're busy managing this massive team. And then in the evenings, after work, you also solve these data science challenges. How do you maintain work-life balance?
Good question. I think so. At the beginning of pandemic, I can say that I wasn't very much aware of all the changes and all the pressure. I think I focused a lot on work, and I tried to basically use work as a distraction to everything else that was going on. I can tell that that's not an effective way of doing things. Actually, it's important to understand your challenges, think about them, and come up with solutions outside of work to fix them. And once I got to that point, I tried to really set up time that I'm going to close my laptop. There's no way that I'm going to open the laptop after this specific time. Or I try to avoid working on weekends, no matter what, except when there's some sort of a deadline or not. And I try to like schedule time to run by the river outside or different things outside of the work. So I have a full schedule of things that I should do beside work to make sure that I have that distance. It's key. I think a lot of people are in the same situation as me, that they're using work as a distraction, especially now that we're working from home. There's not really a line between your life and work anymore. You wake up and you start working. It's very important not to get into that mindset. Work is not a distraction from a stress, anxiety because of pandemic or economical situation. It's very important to find different hobbies for that.
Awesome. How's that going for you to not to close your laptop at a certain hour? I'm trying the same thing, but it's so hard. Like, like you close it and then you're like, oh, I still have to finish this. Well, what's your success rate so far?
I've had good progress, so it's getting better. I think it's important to have a full schedule for other things. So sign up for yoga classes, make sure that you have an alarm for running or exercising outside. I sign up for some galleries in New York that I want to see, even in the weekday, which I didn't used to. So I basically schedule the rest of my day to make sure I definitely have something to do. So I have to close my laptop.
Awesome. That's good. That's good advice. And one more thing, very important topic I think we should touch on is women in data science. So it's you've had tremendous success. Were there any obstacles along the way, and what can you share with our female listeners who are, excited about data science, but they can see that this is indeed like a lot of STEM is a male-dominated space? What kind of encouragement can you share with them?
Yeah, I think that's something that you realize very early on when you go into tech, that there are more men than women. I just think that, so you can't deny that, but I don't think you should look at it as a roadblock or a problem either. The most important thing is to have confidence, and not only confidence to speak up, but also confidence to ask for help. And I think as a woman, you don't have to have insecurities about asking for help, asking for guidance, because you think that, what if people judge me because I'm a woman and I cannot perform as well as a man? These are all in our heads. So really working on those insecurities, making sure that you believe in yourself, you're speaking up, not only in meetings, but also with your team, not being afraid of saying, I want to meet with this influential person in my company, or questioning the status quo, that I think this project is not important. We should divert our focus to this other project. So having that confidence to speak up is very important. And also, I think you just have to have a passion about what you're doing and not being afraid of making mistakes, because people do mistakes. You just have to learn from them and move on. And I think, again, women have maybe more difficulty dealing with mistakes because we think that they're being judged maybe more harshly, which is a reality. I'm not trying to say that reality doesn't happen, but we should basically say, I'm going to do my best. There's going to be mistakes along the way. I'm just going to learn from that, be accountable for those mistakes, and just move on. And most importantly, to make sure that you play fair and square. And again, at the end of the day, it's all about confidence.
I love your comment about asking for help, because everybody asks for help. Like I ask for help all the time, like everybody, regardless of your gender or background, you should be comfortable asking for help. And if you're being judged for asking for help, then you should ask yourself, is that really a company you want to be working for?
Exactly. And actually, you can lead by example. You can basically say, I'm a woman leader and I'm going to speak up and ask for help. So you actually lead by example to all the other women in the company that it's not a sign of weakness. If you need help, you can ask for it. And then even if the company doesn't have that culture, you help building that culture for the company.
Yeah, that's great advice. You spoke about confidence, having the confidence to speak up, to change, to challenge what the company is working on, to the confidence to ask for help. How do you build that confidence?
That's a tough one.
Yeah, yeah.
I was trying to think about how. Again, I don't think I have gained that level of confidence that I want to myself.
Yeah.
It's a day-to-day struggle, I would say. I think being self-aware is very important, understanding your weaknesses and strength, and just double downing on your strength and also work to develop your weaknesses. Once you see yourself that you're actually growing and developing, you are going to build that confidence. I'm still trying to build that for myself because I am self-aware about my weaknesses.
Yeah.
And I'm trying to improve on those. And when I see progress, I'm like, okay, good. Now I can just be more confident in myself. So just self-awareness, I think is the key to build that confidence over time.
Yeah, that's a good example or good advice. Self-awareness to build confidence. Asieh, I have one more question for you. Before we wrap up, and that is, where do you think the future of data science is going for people who are looking to build a career in this field? What should they be preparing for in the next 2 to 3 years?
Well, I think the world is getting more and more data driven. And the key is that now people are generating more data. Everybody and all the population this year, most of the populations are generating data every day. So the data is only growing. Given that the data is growing, the need for data scientists and data analytics and data engineering is only going to grow. I don't think that there is any limit really in the demand for data science in any time in the near future. Some of the fields might get a different name, right? A lot of data scientists are now machine learning engineers or machine learning researchers. So the name changes, but really what you do doesn't change. And the demand for this field is only going to increase. But with that, so that's good that there's demand. But given that now all the industries from healthcare to business management to finance to government, everyone is going to need data scientists and data analytics resources. It's very difficult to know, okay, what skills do I learn? Because based on the industry, you need a different sets of skills. If you work in finance, you have to be a very good technical, you have to be very fluent in a stochastic processing. If you want to work for, let's say, for AWS in Amazon, you have to have a very foundational infrastructure knowledge, although you're doing machine learning on top of that data. So my advice is that choose a field, and in that field, make sure that you are always on the edge of that industry and that field, and you're pushing the envelope and you're questioning the status quo, and you are always on the border of that specific industry, given that it's very difficult to be a knowledge expert now in data science in every possible field.
That's the researcher speaking in you, pushing the borders of of what humanity knows. Great advice. How do you choose a field?
That's I think a lot of that comes from so college. So, for example, if you're very much interested in pure statistics and pure probability theory, you know that you're most likely want to be a researcher. I don't know, either in Microsoft or go to finance and doing quantitative finance or very theoretical mathematics.
Or actuarial, maybe.
Exactly. So really focusing on those fields is more important, and maybe finding an internship in those fields so you can examine whether actually that's what you're looking for. Generally, taking advantage of internship through college is really important because that's the time that I can actually work in multiple industries and find the industry that you're interested in. To me personally, if I never had that internship in Visual IQ, I wouldn't be where I am. Before that, I had no idea about the application of data science in marketing. And I just learned from that by that internship. So that's very important. I think that's a way that you can actually have different experiences and pick a field and just double down on that field.
Fantastic. Asieh, it has been a pleasure. It's been super exciting to speak with you. Before you go, please tell us what are the best places? You already mentioned LinkedIn. Is that the best place to get in touch with you for our listeners?
Yes. I mean, I don't have social media, unfortunately, so I cannot provide like a Facebook or Twitter account. LinkedIn, it would be the best place.
That's perfect.
Really.
That's perfect. And one final question, just a quick one. What's a book that you can recommend to our listeners?
Yeah, I mean, for data science, again, I'm really interested in the theoretical aspect of data science. For me, the go-to book has always been the Pattern Recognition and Machine Learning by Christopher Bishop. Honestly, I've never had a question that I couldn't find the answer in that book. It's really comprehensive from graph theory to neural network to basic classification and regression analysis.
Gotcha. Pattern Recognition in Machine Learning by Christopher Bishop.
Yes.
Awesome. Well, Asieh, thank you very much for coming on the show and sharing your time and insights with us.
Oh, no problem. Thanks for having me.
Thank you, everybody, for sharing this hour with us. And I hope you got a lot of value out of this podcast, got some useful insights, and we're excited to hear about Asieh's story, how she went through academia and her bachelor's, master's, and PhD, and all the exciting research she's done, and also that move to industry and how she is progressing through her career and leading people in the space of data science. My favorite part personally was our discussion about stochastic versus deterministic signals. It was a good refresher of that world, and we don't often talk about it in data science because, for instance, like in marketing or in many other areas of data science, you just don't work with signals. But it was exciting to see that you can use signal processing both in brain-computer interface, and at the same time you can use it in financial modeling. So there are areas where data science will overlap with signal processing, and it's important to be aware that these are two separate or slightly separate domains that you might actually be interested in. If you've never tried signal processing or never look into it, that might be something you're passionate about. Or if, like Asieh, you're coming from an electrical engineering background where there's a lot of signal processing, those skills can be applied in certain areas where data science is also used. As always, you can find the show notes for this episode at superdatascience.com/415. That's superdatascience.com/415. We'll link to Asieh's research papers there. You can read them. Also, Asieh said she'll send through some more information on curse of dimensionality and some other things that we spoke about. So that might be useful to you too. And of course, there you'll find a URL to Asieh's LinkedIn, where you can connect with her, and specifically if you're looking to apply for that job that they're currently hiring for, I would encourage you to connect with Asieh and let her know. As she mentioned, we're there they're at MassMutual, they're looking for an advanced data scientist or a lead data scientist. And if you enjoy this podcast and you know somebody who could be inspired by it, somebody maybe who's in the world of academia or who's excited about signal processing and is considering data science, send the link to them. It's very easy to share this podcast. Just send the link, superdatascience.com/415. On that note, it was very exciting to have you here, and I look forward to seeing you back here next time. Until then, happy analyzing.